Water really is the ultimate connector. It connects landscapes, it connects human communities from upstream to downstream, and it connects animals that come and use the water or live in the water during different times of their life. Animals also move resources across landscapes, but they can do it in all different directions. Uphill, upslope, at different rates of speed. And in so doing, they can really act almost as the biotic circulatory system of the planet. What I became interested in is studying how the animals shape the ecosystems and why it's important to conserve the animals in order to protect the ecosystems in which they live. A lot of my research has focused on animals that move between land and water. I have studied in East Africa the role of hippos, which feed in savanna grasslands at night and then spend their day wallowing in the rivers, as well as things like wildebeests, which don't spend much of their time in the river, but come to it for drinking water, and also it's an important boundary they have to cross during the migration. I've done research studying alligators and how they move between seasonal wetlands and more permanent riverine habitats by moving upland through forest ecosystems. What I want to do as I move forward is develop the tools to start to understand that at a more global scale. A lot of our research is in the Serengeti Mara ecosystem in East Africa. We have a research camp in the Mara Triangle, right in the middle of the Masai Mara National Reserve. It's a rustic research camp, so we have tents and we don't currently have running water or power, but it is a remarkable place to work.
What's really cool is we're in the middle of the reserve, and so there's no fences at all. And so at night, you can hear elephants come through and hippos close by. During the day, we have baboons come through and warthogs. And we maintain a full-time research camp there. So we've got research going on year-round with local staff, although we're not physically there except for in the summers or during discrete field expeditions.
Chris has a great video of when he was writing his dissertation at the camp table. He was like writing on the computer in the morning early. It was quiet, nobody was really around. And all of a sudden,
one female lion walked by and I just froze. I was so surprised. And then I saw one male lion walk right behind her. And so then I jumped back kind of into the tent. And then I got my video out. And the next male lion walked by, just following.
Paying no attention to Chris at all.
Didn't mind me, you know, just a few meters away. It was pretty crazy. It's very dangerous working with wildlife. We take all the precaution we can, and we work with armed rangers for the Conservancy. We have had to run before, but we've been very lucky. The research in my lab tries to understand how microbiomes affect human, animal, and environmental functioning and processes. One of the things we look at is kind of how animals move resources throughout the environment. We try to look at it from a perspective of water being the ultimate conduit of microbes throughout the landscape. So a microbiome is just a collection of microbes, of these little microscopic taxa that all interact with one another, and they can create changes to how our gut functions and how it interacts with our body, or it can create different biochemical environments out in the environment.
People don't normally think about animals as being a big driver of ecosystem processes like nutrient cycling. They think of microbial communities and plant communities as driving the majority of ecosystem processes because that's most of the biomass that we see when we look out on the landscape. But animals are able to have particularly strong effects because they concentrate high-quality nutrients in certain hot spots. So animals can actually have kind of a disproportionately important impact on ecosystem processes.
So I didn't intend to end up in this position when I was young. I started as a saxophone performance major, and that's what I got my undergraduate in. And I just kind of found my way into this field working on microbiomes and working with large wildlife as an avenue to kind of improve our health as humans or animal health and the environmental health, trying to rehabilitate some of those systems.
It was really fun to be able to bring those two areas of kind of experience and expertise and the different tool sets that we tend to have together. I think it's helped us ask maybe creative questions that have gone across disciplines because we have these different disciplinary backgrounds and different skills. Chris is not afraid to ask a question that's unconventional or that defies maybe conventional wisdom about something. And I think that has led to some of the most exciting discoveries that we've made are those questions that challenge, maybe preconceived ideas about the way the world works.
Animals are transforming resources like hippos in the grasslands are taking grass and consuming it, processing the grass in their bodies, and then defecating into the river.
A lot of our research has been focused on studying how big an impact hippos can have on river ecosystems in their native range.
We really got here by asking very basic questions at the beginning, and we kept pulling that thread of inquiry to try to understand how hippos are affecting the river ecosystem. And that question first started out with a very basic conversation with a Maasai man on the bank of the river one day after a large fish kill had occurred in the Mara River. They thought that the fish kill was caused by pesticides that were dumped upstream. Well, it was a flushing of hippo pools. Where we're at now is we're trying to understand the way that different types of hippo pools may be sharing a communal gut microbiome within that pool and how that shared microbiome is affecting the hippo behavior. And so anecdotally, we've seen that hippos that are sharing hippo pools that don't have much flow, that have very anoxic water, conditions very similar to a hippo gut, that they seem to be less stressed.
So my research program right now is investigating these kinds of processes, how animals move between aquatic and terrestrial systems. Most people have seen at some point videos of the wildebeest migration and maybe even these exciting river crossings. When we were there studying the river, what we saw was that occasionally these crossings would result in these large drowning events of hundreds or even thousands of individuals that would drown during a river crossing. Very tragic to see for the individual wildebeest, of course. It makes a very small to no impact on the population because the population is so large relative to the number that drown. But it has a huge impact on the river ecosystem. So many components of the river ecosystem respond to these drownings. Vultures come in within days and start feeding on the carcasses. We see that the carcasses comprise the majority of fish diet, and even months after the carcasses have decomposed into the river, the bones of the wildebeest carcasses remain and slowly leach out nutrients that then grows these algal biofilms that other fish and insects continue to eat. This pulse of resources that comes in from the land through the wildebeest bodies really fuels the river for months or even years afterwards. These themes of my research in the Mara River, I also study in several other systems around the world. So I'm working with colleagues in the Galapagos Islands to look at how Galapagos tortoises move into small freshwater ponds and to the terrestrial system. And we're looking at that here in the southeastern US, looking at these kind of remarkable little seasonal wetlands that exist in the coastal plain and how they become hotspots for carbon storage and also for biodiversity and how those things can interact to influence their role in the landscape.
So working with microbiomes and animals and water, we have some really fascinating ways to collect lots of different types of data. One of the key ways we do it is leaving automated sensors out in the field where we go and retrieve the sensor later after it's been measuring water quality or dissolved oxygen or something. Well, one of the great things about being at UF is the Hypergator research computing resources we have here, because the generation of all this data, you really need, some strong compute resources to process them. So we're very fortunate here.
One idea we're excited about building in the future is developing UF as a center for animal movement and landscape connectivity, where we can really use the campus as a living laboratory for studying animal movement. We can look at how bats move through air, flying out from the famous UF bat houses to forage across the city of Gainesville each night. And we can look at how alligators, the UF mascot, move across their favorite little water bodies, but also move over land, crossing at crosswalks, moving through canals, and really moving across the campus maybe more than we all appreciate. And we envision that as an opportunity to track animals through courses where we can teach students about handling and tracking wildlife as well as analyzing animal movement patterns, and as an opportunity for outreach and education to the broader community about how animals move across and shape the UF campus and connect it with the broader Gainesville region. We all see animals and enjoy seeing animals, right, in our environment and our daily lives. We see birds in our yard, we see fireflies at night, we see deer maybe moving through our neighborhood. The animals that we share our world with also help shape our world and provide many of the ecosystem services that we depend on without even knowing the role the animals are playing in that process. And so it's important to protect biodiversity just for its own sake. And also, it's important to protect it because it continues to protect all these different services that we rely on as human communities.